Hello team, today's challenge is Transposed Matrix, where we're given a matrix that looks, well, kind of like this. There's different versions, and we need to make it look like this. So all of the column 1 items become row 1, column 2, row 2, column 3, row 3. I, of course, am not doing 0 index here, but that would be 0 to 0, 1 to 1, 2 to 2 if we were doing it that way. Fun times, okay? Hopefully not surprising on this one is the fact that this is the base component if we wanted to rotate the matrix, which is a challenge that we've seen a few times in the past, right? Where we've rotated things in order to get at that information. So we're going to use exactly that bit of base code to get this done. Right here, clearing away this because I don't need it, but we are going to start with a reduce, which is how I've done it in the past, right? And that takes the accumulator and the current, and we send that out to this. Now we are going to return an array because that's what we're expecting, right? We just return the array, not a problem. Inside of here, we return the accumulator because if we don't, bad things happen, right? And then we do stuff. So we do stuff on the current. And for that, we're in it for a second loop. Again, I've said this in previous videos. Anytime we're doing a matrix, we're probably doing 2 loops, one for the rows, one for the columns, right? And this is no different. So inside of here, we get the element and the index. And this index is where the magic happens. So the index on the row becomes the index for the index of the column becomes the index of the row. And hopefully that'll make sense once we actually write the code. So right here, we're going to do that. That's going to be accumulator index, right? So the row is going to be equal to the accumulator index plus the element. So we spread that out just like this, accumulator, doing it right, index, just like this, and attach the element. In theory, this would work. It absolutely won't because right now this array is empty, which means that this might not exist, right? So in the past, we grab onto this part here after the 3 dots, wrap it in parentheses, and use that nullish coalescing to get the job done, okay? At which point, it's done, right? And it's done just that fast. We've basically used this index to change from columns to rows. That's the whole thing. So if we go and we look at this again, bringing this in, this is what we did, fixing my indenting, but 1 and 4 became row 1 and 4. 2 and 5 became 2 and 5, 3 and 6, exactly like we did. And again, this is the base form for things like rotating the matrix. So in that case, what we have is we have something like this, right? This is something that we saw a long time ago, right? I'll link to the video, but we started with this sort of thing. So if we wanted to rotate, we reverse the rows first. And we do that because we want the numbers to slide into the correct positions. So by rotating it, we're able to by reversing it, we're able to rotate it or make it look like it rotates 90 degrees clockwise, okay? Which is what happens here. Again, once we're in this stage, it's exactly the same as what was above. So 4, 1, 5, 2, 6, 4. 4, 1, 5, 2, 6, 3. Sorry, I said 6, 1, didn't I? 6, 3. So this part here, right, this transpose is a base component in a lot of these different matrix systems. And getting a really solid handle on it is going to help you. Whether it's this code or something else, you can reuse this over and over and over again. And in fact, I have in many challenges. So here it is, the base component of that doing exactly what it's meant to. Did you like it? Did you hate it? Did you find a different way? Share all that in the comments. Otherwise, today this has been Transposed Matrix, and I will see you tomorrow.